Hello, this is Kyle again, and this video is going to be going through steps 6 and 7, mostly focusing on step 7. There'll be another video after this to focus on the final few steps. In the previous two videos, we went through steps 1 through 5. Now we're going to focus on working from our plan to a functional program. To get started, here's the entire plan we developed over the last two videos in mostly plain text. This is all of my pseudocode from the planning steps. Then I open up my development environment, which could be Atom, could be VS Code, could be idle or Notepad, or just about anything. Hopefully you've watched the Getting Started video series and you know what is meant by this. In this case, I'm using VS Code, but I'll try to show off the finished product in Atom as well. Recall that step 6 is setting up the development environment. We have to install an editor or IDE if necessary, and then we have to open it, which isn't very hard. In some cases, with a variety of technologies and services you might be using, setting up a development environment means a lot more than running one application. For us, at least, we should also set up a proper space for our project. Let's make a folder somewhere memorable. If you're really organized, you'll have a folder structure like semester1/prog1205/programs, and then you'll keep a separate folder for other courses like that. Maybe in that programs folder, I'll make another folder called commission. We'll save our new empty file in the commission folder as commission.py. As you ought to know, .py is the file extension for Python code files. As always, pay attention to file names. I hate to contradict myself, but I had said Pascal case before, but really, I double-checked the Python style guide, and it says files should have short, all lowercase names. Underscores can be used in the module name if it improves readability. So I'm going to name it just like this, and keep it lowercase. Going to bring something in here. As discussed in the Getting Started video series, I've started with some opening comments that include some basic necessary information. My name, the date, and what this program is. You might notice the requirements are completely copied out of our slides. Now we're going to start coding. Remember that brilliant plan we wrote as pseudocode? Let's highlight that and copy those completely. Now I'll go back to my development environment and I'm going to paste them. Right now, this just looks like a big mess of non-Python code. Depending on your IDE, this might be popping up error messages right away. Thankfully, most IDEs have an option to turn several lines of text into comments. We'll just comment out all of this pseudocode. And if we don't have a way to mass comment things, then we'll just literally put a comment symbol, hashtag or whatever at the start of each line. Mass commenting in both Atom and VS Code can be done by going to Edit, Toggle Comments, or Control \\. If you mass comment the entire text, you'll see the number sign or hashtag or pound sign or little tic-tac-toe thingy at the left. Not only does this put our plan directly in the code file so we can refer to it while we code, but this plan makes perfect comments to just leave in so our code is more understandable. Now the next step is to go through and translate each line of pseudocode into usable Python code. This isn't always going to be perfect, clean, line-by-line conversion, but let's see how it goes. So first off, in my declaration section, I'm defining a high sales limit. As I said in a prior video, Python doesn't really have constants, but there's a naming convention we use to indicate values like this. So we simply write the name we're using in uppercase with underscores and assign it the value 15,000.0. And I'll put that 0.0 at the end of the line, which will help ensure it's treated as a decimal value, a float value. So that's my high sales limit. Now we'll go ahead and fill in the rest of those constants. As I'm typing, you might note the colors being used depending on my IDE. To keep it simple, things that are being treated as literal values are in one color, named values are in another color, and comments are typically in green. If I were to accidentally put a semicolon in here, maybe because I'm used to C# or Java or something, you might see it pop up in another color to bring attention to the fact that I've done something wrong. Again, this can vary depending on your development environment. My plan also indicates the variables we need, and we are indeed going to use these. If we were in another programming language, this would be a great time and place to declare my variables, but Python doesn't have this since variables are dynamically typed. So I'm actually just going to remove this line. With that, now we're into the input part of the program. And the first thing we need to do is get the gross sales from the user. This part is going to deviate very slightly from the plan, and that's because of the way Python treats numbers differently from text. So I have to try and accept the number representing the gross sales from the user as a floating point number, and I also have to do something in the case that it fails. So this is going to use something we haven't used before, but it's very common, and that's a try block and an accept block. This is a bit of an advanced feature to talk about right now. but it actually is the best way to make sure a number is properly accepted. You won't need to do this on lab 1, but it is a good way to get this working in a proper way. First, I'm going to open up my try block, and then I'm going to assign the value to the gross sales variable, which I'm really using for the first time here. I'm going to try and force it to be converted to a float, and I'm going to use the input function to prompt the user with this message that we planned, and we're going to do that all on one line. So that means it's going to state that message to the user, it's going to try and accept their input, it's going to see if it can be treated as a floating point number, a decimal number, and then it's going to store it in the gross sales variable. And there'll be a different set of actions that will happen if this does not convert nicely to a floating point number. So what this is going to do is it's going to, if the gross sales was not entered in a valid way by any means, it's going to just ensure it's an invalid number by setting it to something less than 0. Minimum sales we set equal to 0. And we're going to set it to minimum sales minus 1, so it will always be treated as a negative and thus always fail the next part of the validation. Now we have to proceed with the plan and do a little bit more data validation. We want to make sure gross sales is greater than 0, and we also know this will fail if it's not numeric. So we can just check if gross sales is less than minimum sales. And we use a colon at the end of if statements in Python, then we print out our message. Note how this relates to our plan. Anytime there's a question in the plan that ends up being equivalent to an if statement in the code. Don't get hung up on the details of that right now, as you're not expected to use code with if logic until after lab 1. All this has done is told us what will happen if gross sales is invalid. To write the alternative that we use if gross sales is valid, we use an else statement, again with a colon. And here's where we carry on with processing. One of the last things we have to do here is determine the commission rate based on the gross sales. And again, this is planned using a series of questions. If the gross sales is greater than the high sales limit, then I want to do one thing. Otherwise, I want to do something else. Again, we cover the coding of this more later, so if this makes sense to you right now, then you should be feeling good. Now here's my coded program logic to determine what the commission rate is. We've got a condition for using the high rate, a condition for using the mid rate, and then by method of elimination, if the other conditions aren't met, we would use the low rate. One thing that's new in there is the word elif, which is a mixture of else and if that Python uses. This means if the first condition is not met, check this other condition. The final step is pretty much directly from this design document, but this is the calculation. The commission amount is equal to the gross sales times the commission rate. And with that, we are pretty much done the processing part of this program. Let's move on to the output step. This is really just a single print statement, the kind of thing you should have seen already in the getting started videos. I'll write this using concatenation, which is combining strings together. This is partly a string I'm writing here, and I'm using a slash before the apostrophe here as what is called an escape character, since apostrophes mean something in Python code. This just means, hey Python, just write an apostrophe here instead of doing something fancy. We'll use a plus sign to concatenate, and well, there are a lot of ways I could add the actual number in here, but we've been asked to format it as currency. I can add a $sign in here and then round the commission amount to 2 decimal places. I can use the round function, but I also have to change it to a string so that it's treated as text, or this won't work. As I said, there are a lot of ways we could do this, but I thought this was easiest to understand. Now this is pretty close to done, and we could test this, but I can tell you, spoiler alert, this is missing a step of some importance. When we run a program like this in idle or Atom or VS Code, we can see the whole program running and we get returned to the console. But if we were running this program from the command line or something, the program would very suddenly end after the result was displayed, and the window might instantly close. It's possible you wouldn't even see anything. So we're going to add in a step here that pauses the output at the end of the program until the user presses enter, which is a pretty normal thing to do. We neglected to do this in our plan. All we need is another input statement, and we'll just put a message in it. We don't even care what the user's input is. We're just going to wait until they press enter. I'll add a /n to the beginning. That's another escape character that means insert a new line here. Now let's save it. Let's call this done. Here is a very quick look at how the exact same code appears in Atom with default settings. That was steps 6 and 7 about setting up the development environment and converting from pseudocode to Python code. There were a lot of parts there that I told you we don't need to worry much about right now, but here are a couple questions you should be able to answer. What is setting up a development environment? And I'm not looking for a Google definition here. What does that mean for us? How can you use pseudocode to inform a program's code and commenting? And how do you use constants in Python? And there will be one more video, hopefully a shorter one, about the remaining steps.